Good morning, good afternoon, everybody. I'm Randy Andracki. I'm one of the Mechanical Solution Division Application Engineers here over at Imagine It. I've been in the mechanical manufacturing CAD industry for over 20 years, so quite a bit of experience there supporting and training customers with Autocad, Inventor, the Vault products, Autocad Electrical and Fusion. And today I put together a presentation, as you saw in our emails, that where we're going to talk about skeletal modeling, how you can actually drive an assembly with a part. We're going to get into a couple of techniques with that. So we'll talk here as you should all be able to see this next slide here. What is skeletal modeling? Essentially, we're going to take, and let's see if I can get my pointer to point there a little bit. We're going to how I can just design a small portion, one of the troughs, or one of the trowels, I mean, over here in this side here. We're just going to make some wireframe geometry. That's called our skeleton, and we'll show you how we can drive our model with that. Essentially, we're going to get into a variety of different commands. Some of the advantages that we talk about with skeletal modeling is skeletal modeling. So it's just simply, it's easier to be able to view things in the single part that we're going to show you and be able to make changes. You can reference a single part file, and that single part file, as I mentioned, will allow you to drive your assembly model. We'll get into a few commands. Some of the commands you might be familiar with. There might be some newer ones for you, such as sketch blocks, creating blocks. Those of you that are familiar with AutoCAD and creating blocks, we're going to do a similar type thing in Inventor. And then we'll get into constraining them and working with some derived parts. So to kick things off, I'm just going to go through basic 5 steps that we're going to use for creating a skeletal model. Simply, we're going to use some logicals. We're going to create several sketches, as you see here on the slide, and we're going to name each of the sketches to equal the part that we're going to design. So it gives us a little bit of guidance as we're trying to view our model. If we have, this will be our spider here, so I'll know that when I'm dealing with the spider, I'm dealing with this sketch, or the arm length that we're going to deal with, and we'll deal with this particular sketch. So I'm going to do some renaming that you'll see as I go through the steps to be able to manage my model. It helps further down the road when I start to derive some parts from that. So using some logical names to help identify the components will be a big help. After we've created the sketches, I'm also going to be using some parameters, not all parameters, some dimensions I'll just accept them as defaults, but some of the critical dimensions that I'm going to be concerned about or think I might be concerned about, I'm going to apply some names, some parameter names to them. And again, I'm going to use some logical names like spider width, the width of this part here, or the standoff, the length of this particular component here. So that way, as I, again, go further down the process of deriving components, you'll see where these will come into play and help out with the design process. Next step we're going to do then, after we've created our sketch and applied some dimensions, is we're going to just drop a surface, just a simple patch surface. And I can make the surface or I cannot make the surface. There's actually a couple of ways here that we can go. I'm going to go with the surface option in this particular case because it allows me to apply some thicknesses to my model, and we'll take you through those steps. Once I've built my surface part and each of the skeleton shapes of my particular design, I'm going to convert that to an assembly, and we're going to convert each part to, or each skeleton shape to a separate part, and then we're going to merge that all into a single assembly and put that together, and we'll show you how we can then drive the assembly using the dimensions in the skeleton model. So this would then be our end result here. So let's get into and then any changes that we make here to what we call our master part model will apply to the assembly. So let's get into the assembly here, and let's start doing a little bit of this. So on the screen, I'm simply going to, I'm going to get in, I'm going to just start pretending that I'm building this, this subassembly from scratch, and I just want to be able to lay out some ideas. So let me just isolate our design here, and actually let's turn it off a little bit further. And I'm going to focus in on this area here. And what I want to do is I'm going to start, I want to think about, well, what geometry does it take to really design this shaft, this pin, this arm? Really, I just need a line and a circle. For this particular, for the trowel, I really just need a rectangle. So I'm going to begin a new file here. And let me split my screen here, so that way you could see both screens at the same time. Now on this side here, let's zoom up a little bit there for you. On this side here, I'm going to start creating the initial sketches for some of the basic parts. So I'm going to design or create a skeleton for the standoff. So we're going to put that on this plane here. And I'll just get into a right side view, and we're just going to use just a simple sketch. We'll keep it simple because, like we said, the topic is skeletal modeling, so we're not getting in depth very much into each of these parts. But I will be somewhat neat. I'm not going to get too reckless in how I sketch this geometry here. And let's just see what we can get in terms of automatic dimension. Okay, let's just drop a few dimensions on here. And for this dimension, I'm going to call this standoff length, and we're going to make it equal 7. Get in here, and I'll call this our standoff height, and it's going to equal 1.8. Call that at a 1/2 inch. Let's drop in a couple of angular dimensions. And I want to make sure that these two edges are going to be the same. So I'm going to apply some logic here to the design. Here we'll call this, we'll just make this be 1/4 of that. And I've got 2 constraints left. I'm just going to apply a final constraint here to my sketch. And that's all I need for this particular model here. Now I'm going to rename this sketch. So we talked about using some logical names to the sketches. And since this is going to be the standoff, I'm going to name this sketch standoff. And we're all set with that one. Next part that we want to create or start thinking about, so keep in mind as you're designing, obviously you're not going to know that you want this as your complete final design, but you have an idea where you're going to be going with things as you're designing or laying out your skeleton model. So for my next part that I want to create, start building, I'm going to, let's just create a sketch, and let's put, whoop. Yeah, I did that right. Thought I picked in correctly. Let's just draw our next shape. We're going to make it be just a simple rectangle. And we'll give it a few dimensions here. This is going to be our trowel, so I will define this as trowel length. We're going to make that equal 7. We'll call this one trowel width equal to 5. And I'll finish this off. We'll divide that one by 2. And we'll do the same thing here. We're going to call this, we're going to name this trowel. Go figure. The next part that we want to do, thinking about the arm here, And what I need, so what I want to do is I'm just going to make a line to represent that shaft, that arm, however you want to refer to it. So what I'm going to do is I'm going to reference everything. I'm referencing it, you may have noticed, off of the common origin at the top level of our part. So I want to reference this plane for my next sketch. So I turn that plane on so that way I could press and drag and just tell Inventor that I'd like that one to be 2 inches up. And all I want to do at this point for this arm, and we'll call that arm length. It's just going to be a single line. That's all I know about it at the moment. And we'll tie it to, oh, not that one. I wanted this one here. There we go. So it'll slide right along the center, but I want to be able to define its length. I want to be able to reference that. And we're going to call this arm length, and we'll make it be 8 inches long. And I might even have an idea, well, I don't know. I don't know where it's exactly going to go along here. So I'm just going to leave that much of it alone. And we'll create our next sketch. Now the next sketch wants to be the diameter of the arm, or some diameter. I know it's going to be either rectangle or diameter. It's going to have some shape to it. So I'm going to put a plane at the end of this arm length, what I called arm length line, and I can use that plane then. We'll make our new sketch, and let's just project our point. We need to project that point because I want to make sure that I have everything at the origins on the correct planes and so on. And let's have this one be just a circle. I made it, and I'll call that one arm DIA. We're going to make it equal 1/2 inch. And I could, and just down to the last part now, I'm going to create so everything I'm kind of working up at this level now, and since the spider is supposed to have connected at the center of the arm, I'm going to make one more final sketch here. And we're going to call that, that'll be our actual spider. And we'll call it spider width equal to 6. And I'll make my sides all be equal in length, but I want to, let's see, line this up so that it'll be lined up with the center. And I'm going to add one more thing, because I'd like to be able to have some control as to the distance from the rest of our mechanism. So I'm going to add a construction line. I could add it now. I could add it later if I thought maybe I didn't think about it right away. But as you know, you're all Inventor users, so you can always edit your sketches. And I'm just going to drop in. We're going to call it 11 just for the sake of conversation here. But I need to get caught up on my sketches here because I want to make sure I have everything named properly, which just helps out later down the road. Call this one, this is the arm diameter there. So that's really all I would need to do to build, at this point for this design. It's all, I don't know, conceptually this is where we're at with things. So I'm going to finish that off. And our next step in building this, what we'll call our master skeleton model, keep in mind how everything is referencing from the original plane here. I'm going to take and I'm going to add some surfaces. And the surfaces are going to be used simply to, let's apply that, add a thickness when we start to convert this to a solid model. And say we're done with that. Now, Let's save our assembly here. Yeah, we'll save it to the D version. We'll overwrite that. So we kind of get an idea how this skeleton here might relate to some idea that we had towards our final design here. I'm going to close this window here now, because what we're going to do is I'm going to start making our assembly for our skeleton here. So let's close this up. And I don't need to save that. And the next thing we're going to do is I'm going to build 4 parts, one for each of these components that we have here. I'll use our new command. It can be a sheet metal part. I can do skeletal modeling with sheet metal components, sheet metal design. In this case, we're going to use our standard component. And I'm going to name, right away, I'm going to name this one. And I know it's going to be the standoff. And what I'm going to do is I want to derive. So I'm going to use our derive command. And I'm going to pick that skeleton part which I created. Yep, the one I just created today, 1216. And here's where the names will come in handy now. Except for the surface side, I'm going to pick, and what's the plus, what does the gray and the yellow mean? The gray means exclude that geometry in my derive command. The yellow circle with the plus means select the geometry. So that's the surface I want to use. Turn the rest of it off. I also want to be able to tell the system what sketches I want to use. This is the standoff, not the arm length, so use that sketch. In terms of work geometry, if I have work planes in there that I specifically needed to use, I could select them. I'm just going to leave the default. It doesn't matter in this particular case. And for my parameters, if I created any user-defined parameters, I could select them at this point. Or I can, and then now since this is the standoff, I want to make sure that when I create that part, I get the 2 critical dimensions at least that I could use to control the size of the design. And we'll accept that. And that is my first shape called standoff. We'll just save that. And we'll close out of that. I'm going to create the next part. And we'll do the same thing. We're going to derive from that original sketch that I created. And we'll go through. Now that surface, nope, I don't want that one. This is going to be the trowel. So I'll select that surface. And the sketches, I'll select the trowel, not the arm. And for the parameters, I'll select not the standoff, but I'll select the 2 trowel dimensions that I wanted to be concerned about. I think I got everything. Let's accept that. And we're going to name that trowel, going in the right location. And we'll close that up. I don't need it open anymore. I'm going to do 2 more real quick here. Derive from that parent master sketch that I created. I don't want either one of those 2 surfaces. Which one is that? It's the little circle that I have here for the arm diameter or size. I'm going to turn the spider off for the sketches. Let's grab both of these parameters, both of these dimensions, and sketches. And for the dimensional information, let's grab these. Let's just turn everything off and turn these 2 on. I want to grab just those 2 dimensions. Let's save that. That was the arm. Last one, we're going to derive from the, again, back to the master. Green arrow indicates that surface has been utilized. This is the last one. It does correspond. I expect to see that. For the sketch, let's just select the spider sketch. For the parameters, let's just select the spider width. All right. So you see we're naming our parameters. We're naming our sketches. Come in handy down the road. I could even get to where I name the surfaces accordingly as well. I just chose not to in this particular case. And let's save this. This was what? This is the spider. So I've got all four parts now that I created, and I'm back to the original part that I started up now, where I created. Essentially, this is my assembly, is what it is. Now what I want to do is I want to start designing or converting each of these individual sketches into a part. So I'm going to build or start up a new assembly. Excuse me, not new assembly. We're going to we'll build a new assembly. Yep. And what I want to do is I'm going to go and I want to grab all four of those parts that I just created. So here's the time they were created, so it kind of corresponds with the time on your computer. And let's place those four parts. Get into an isometric view here. Zoom that down. And Inventor, as many of you know, I'm sure, allows you to place multiple components at one time. And I could place multiple instances of them if I would like, or just hit an escape, and I have all my parts placed. And it will separate them, will spread them out so that I could conveniently see and be able to pick and place how I would like to constrain them. But because I used a common origin in my master skeleton model as I created these, what I can do now is, here are my parts, here's my assembly. I'm going to use my ground and root command in our productivity. So from our assembly tab, under the productivity panel, I'm going to come to ground and root. What that will do is that will apply, and let me open up two of these so that you'll see, do a third one. When I say apply, notice how constraints were generated between the arm and the plane. So everything was constrained and essentially assembled together to the common origin. So that's an important key here, is working from the common origin. Now, I can activate each of these parts if I would like, and if I take a look, it kind of looks like I've got two of the same thing, when in fact I don't. This is my assembly. This one is my skeleton model. I'm going to make sure I save my assembly here. So let's do that. Let's save this assembly to that name. And what I want to do now is I want to start, we're ready for starting to convert some things to 3D, add some dimension to it. So I'm going to go through each of the parts here now and just activate the part. And here's where the surface comes in handy. It allows me to use the command thicken or offset. If I pick that surface, I could then apply, well, if I had a parameter that I used, in this case one of these parameters doesn't work, but I'm just going to specify a 1/2 inch, and let's do a midplane offset. So I have a part created, I have a solid created now, and it appears from the solid, or appears as a solid. I start to see my feature tree build. Here's the original part that was the skeleton model that was used to initially generate this part. So this part is pointing over to here then. Let's go through the next one. Back up. Let's go into our trowel. I'm going to change my screen size a little bit here. We really just need to see a small version of that. It's nice if we could see a bigger version of this screen here. And let's do the same thing here. Let's apply a thickness. And when I give the thickness, I can control the direction, mid-plane, specify. Maybe I want it to be 0.2. Go back. Let's go to our arm. Do a similar thing here. And we're going to call that 7 or 8. Or I can pick list parameters. I have arm length in there. So now, because I typed in the value, there we go. We have the arm built up. And the last thing would be the spider. So as I look at my tree structure here, changing to the Models tab of the browser, I can see how the features are starting to build in each of the components. And I now have a solid as opposed to just a surface model. My last part here, the spider, if I apply my thickness there, we'll give it, we're going to just, not 2, we'll give it 1. And we're going to go with that height. Kind of get some perspective on what we've done here. And we're all set now. Let's turn off some of our, let's see, I can't see if I can move this aside. I have a menu in the way from the WebEx. Let's turn off our construction surfaces and our sketches. There we go. So that's our design as we have it at this point. So this is driven from this single part skeleton master sketch that I've created. So if I were to change the length of the arm to 9, add updates. If I come into here, my update is active, or use Control L, and it changes the length. If I want to control where the arm is at, I could activate the sketch, add some additional information. So it's easier to visualize and be able to make changes early on in the skeleton model, as opposed to when you have this assembly placed into an area where there's a lot of geometry that makes it difficult to visualize. We'll update that. Again, the same thing here. Do an update. There, we've got that one updated now. Or back to changing the distance between the spider and the standoff. Whatever type of change I need based on any dimensions that I placed in here. So this is an example of where I would develop just a simple master skeleton model and upgrade it to 3D and start adding all your, doing the rest of your modeling in each of the components. Build your design detail, bring it into the main final assembly, and so on. The next example that I have here set up for you is similar, but using sketches from an Autocad drawing. Let me close out of this here. I'll save that, just in case there are any questions that come up after the presentation. And let's open up our next one. We'll go to Layout, give you an idea. Let me open up that one. I'm going to open up all 3 of these. That way we can talk about what I'm going to do. There we go. So essentially, this is going to be our end result, starting with this. If you have, and this is going to be a combination of, it's a form of skeletal modeling. We're dealing with wireframe geometry that allows us to get create an assembly at the sketch level, and even a subassembly. We'll get into how we can build a subassembly in a sketch, or at the sketch level. And the geometry in this case came from Autocad Drawing, so I carefully picked what geometry makes sense to bring over. I didn't just select the entire drawing. So I'll turn, and we'll name each of the sketches here. So I'm going to turn this drawing off, and let's finish assembling this one. And I'll bring this over a little bit. That way we'll get a better idea of what it looks like on the screen there. There we go. So what we have here is, if I take a look in my browser tree, let's narrow that up a little bit. I've got one sketch. In the sketch, I have a part called middle brace, upper bracket, top arm, and lower arm. I can pick on each of these parts, and I have constraints because I've applied constraints between each of the circles to assemble them. If I edit the sketch, I can use these constraints to finish constraining the constraints that we're familiar with when just doing 2D sketching. I can generate the relationships between each of the parts. How the parts were created was by using the create block command. So what I'll do here is let's finish assembling each of these parts, because I have this particular shape here, which I would like to, and I see that when I get the constraints in there, I can start seeing how my components are going to move. But I want to make sure that in this case, these two parts always stay concentric. So now as I move that part, I'm in the middle of my command there. Can't do that when you're in the command. There we go. So now how did I build these sketches? Let's do that. Let's complete the task using the cylinder. I have two pieces of the cylinder housing and the cylinder piston, and I'm going to create a subassembly out of them. I'm going to use my create block command. I'm in the sketch tab, and earlier we're going to select what geometry we'd like to have in that sketch, and we'll give it a name. This is going to be is that one. That is the cylinder housing. Let's do the last one. So I see now here, I have my cylinder housing appearing here. Now let's do the next one, and we'll call that cylinder piston. Now I can take and move these parts around. I can assemble them as actual components, because these are going to be act as an individual component. If I'd like the piston to be concentric to the housing, and if I'd like the piston to mount to this component here, I now have, and as I drag my assembly here, I see that I've got parts that start to move. Now, I can further take and tell Inventor that I'd like these two parts actually to be a subassembly. So if I have those parts selected, or or pick them using the create block command. I can create an assembly out of them. Call it cylinder assembly. And I see now that I've actually built my assembly structure. Individual components, subassembly with 2 parts in there. Now the challenge now what happened then is I can no longer move my arm because this is all one part. So those of you that have done assembly modeling before and needed components within a subassembly to move, you're familiar with the flexible option. I can make at this level my subassembly flexible as well, and now I can take and I can move my parts based on the constraints that have been applied throughout the entire sketch. The next task then is how do I make this look like this. So let's just zoom around to that a little bit. And we're going to activate each part. So I'm going to go in and let's activate the top arm. Excuse me, missed a step here. We need to make this all into an assembly first of all. So what we're going to do is we're going to say I want to make an assembly. I want to make components, and when I pick this sketch, the entire structure, including the subassembly, displays in the window here. Specify my names, all the familiar information for what data files I want generated, where I would like them generated to. But let's go to the next portion of this dialog box. And I want you to notice that part of what Make Components does is it recognizes that sketch of cylinder assembly was a subassembly, and that has 2 components in it. So this command is applying the correct templates to each of the parts, the assembly template, and back down to parts. Control what type of component we want it to be, if it's just a reference, an inseparable, weldments, etc., where we want the files to go, and let's go for it. Now the file that I'm in, it opened up the file that I just created, and that's being the IEM, and I see my assembly structure and my flexible cylinder in this particular case. Now I could still pick on these parts, and now I have individual components which I can open up and convert them to 3D. So I could, let's rotate this model around a little bit, and let's do some of that. So for the top arm, let's activate that part, and let's extrude it. I'm going to extrude it. I'm going to use a symmetric extrusion, about a midpoint, specify the thickness of it. Let's go to our next part. Let's go to our upper bracket. So now I see that's the component that's active here. Let's extrude that one. You see how it's going to extrude in that direction. The problem we have is that it's extruding into this component here. So what I want to do is I want to refine my from option for this command. I want to say, well, I want you to extrude that distance, but start from here. So I selected that face, and it's referencing that sketch, but starting the extrusion from the face that I selected. And I want to do another one. Using the same extrusion. Tell that to go from this face. In this case, I need to flip the direction. And we're all set. Say OK, OK. Back out to that. So I've got one part. So this is 2 extrusions in a single part. I'll do one more part. Let's go back and let's do this. Let me see. Is that the top arm? No, that's the middle brace. So let's do middle brace here. So I'll extrude that one. And I'm going to have to do the same thing. Tell it, well, I want you to start from that face. And I'll just accept the default thickness for it. And we're set. Now in this case, maybe I would like to have, this is going to be two separate parts. In the case of this one, maybe we're going to add some additional features that'll join this so it'll all be one component. But this one, we're going to we'll make a separate, another copy of it, and we'll apply our constraints that we have an insert constraint at that location, and let's just make sure the parts are going to be concentric about that point there. And we're all set. Add some color to this. And we'll get a little bit of color now. I don't need to complete my designs. Many times there's parts that you're not sure which part you're going to be using throughout the design process. So I could, at this point, I have all my parts together where just the skeleton of my piston, this piston is enough to join and allow me to see how the motion is going to work. Maybe I have some area here which I need to be able to add some design into before I can decide on what cylinder is actually going to fit in there. I don't even need to have this much detail to the cylinder. I could just have a single line from this hole to this hole representing the housing, and a single line from this hole to, or, well, not quite what I said. I don't want one line between the two holes, but a line representing the housing and another line representing the piston, and then constrain them accordingly. And that really is the minimum amount of geometry. So that's more detailed than I really needed, but still reflective of a skeletal model. So that is the presentation that I had put together today to kind of give you an idea of how we can take and use some simple forms of geometry at the 2D level to drive our 3D. The first example showing where we had an individual part that actually drove our assembly, and in this case I had several sketches that I was able to write out to individual components and convert them to 3D.